All right, so now on to example 3, where we're going to evaluate the composition, just like we did in example number 2. But the difference with these problems is you notice that these values are not values that we're familiar with on the unit circle. You know, you can see here 0, -1/2, -1, and those are all values that were on the unit circle. And when we look at here, we see that these values are not on the unit circle. So what we're going to have to do is actually go back to the basics, go back to what we first understood our trigonometric functions from, and that is with triangles. Now, again, we just use the unit circle as an aid to kind of help us with identifying sine, cosine, tangent, because, you know, when we recognize the hypotenuse is 1, we could simplify things. But now we realize these are not values that create coordinate points that are on the unit circle, right? Because if I was going to do like 4/5, like for cosine, like the hypotenuse is 5, right? For points on the unit circle, the hypotenuse was 1. So now what we're going to have to do is we're going to have to go back to our understanding of right triangles and our trigonometric functions. So remember, cosine is going to be adjacent over hypotenuse actually. So I'm actually wrote that angle that in the wrong spot. So let's put that over here. Actually, I'm going to, for each one of these, I'm going to do that. I'll rewrite the triangle down here. So remember, when we're looking for the cosine inverse, we're looking for the angle. We're looking for the angle that produces the cosine of 4/5. So basically, you know, you're looking at cosine of what angle is going to give us, you know, 4/5. What is that triangle going to look like? So for all these problems, what I'm going to do is I'm just going to draw a triangle that would create that. So if I had a triangle here, and this would be 4/5. So by using the cosine inverse, I can create this angle that creates that cosine value of 4/5. Now it's basically saying, find the sine of whatever that angle is. So when you do cosine inverse of 4/5, you're getting some angle, right? We don't know what that angle's value is, but we know that that is the angle with the relationship of cosine of 4/5. Now it's basically asking us to find the sine of that angle. So therefore, I need to be able to figure out what this opposite side is. And let's just call this, you know, y in this case. So now I'm just going to use Pythagorean Theorem to figure that out. So I'll do 5 squared is equal to 4 squared plus y squared. And you could either do the Pythagorean theorem, or you could also see that this is a Pythagorean triple. So therefore, this is going to be equal to, that is going to be equal to 3. So the sine of this angle, remember, you know, we know that now that's 3. So the sine of this angle is going to be 3/5. Okay, now let's do another one. We have sine inverse of 1/5. So again, the sine inverse is going to give us some angle. So let's just change our angle now. Let's just use alpha. So the sine is going to give us 1/3. Okay, and now it's looking to us for find the tangent of this angle alpha. Like sine inverse of 1/3 gives us some angle alpha. Now basically we need to find the tangent of alpha, right? So that's basically now what we're trying to do, is what is the tangent of alpha? Well, the tangent of alpha is obviously going to be whatever, we need to figure out what the side length is. So again, I'll use the Pythagorean theorem. So in this case, it's not a Pythagorean triple. So I'll have 3 squared is equal to 1 squared plus x squared. And that's going to be 9 equals 1 plus x squared. Subtract 1, 8 is equal to x squared. And then now I'm just going to introduce the square root. Now, again, since we know we have a positive value here, the inverse, we know we're going to remain in this first quadrant. So therefore, we don't need to include any negative values. All right. So therefore, our brown here, when we simplify the square root of 8, we're going to have 2 square root of 2 is equal to x. So that's going to be 2 square root of 2. So again, now it's looking us to find the tangent. So that's going to equal to 1/2 square root of 2. And then we can go ahead and rationalize the denominator by multiplying by the square root of 2/2. And what we'd get is the square root of 2. When you multiply on top and bottom, if you want me to show my work, I might as well just show my work. Why not? I got a little extra time today. And then that gives you the square root of 2. Square root of 2 times square root of 2 is going to equal 2. 2 times 2 is 4. I don't know why I didn't show my work, because obviously I got the answer wrong. So let's go ahead and fix that. So that's why it can be helpful to show your work. I was doing some math in my head and boom, there you go. All right, now this one is important. This one's interesting because you can see there's a negative value here. So, in these first two triangles, I just drew them in space. And the reason why I drew them in space is because, remember, when we're looking at all of our trigonometric functions, when we're doing the inverse and the tangent and everything else, if we have our angles in the first quadrant, we really don't need to worry about them being defined anywhere else, because the restrictions of our inverse trigonometric functions always include the first quadrant. So when we have positive values, I just kind of created these within the first quadrant, basically, and we didn't really need to worry about them not being within a restriction. However, tangent of -3/2 is interesting, because when we look at this, we're trying to find the tangent inverse, right? And remember, tangent is opposite over adjacent. So our triangle could look like this or look like that. And that's what we previously kind of discussed. Let's use beta. Just trying to change up my angles. Okay, so that's what we previously discussed in previous chapters. Well, if one of these is negative, then in this case, it would have to be 3 over -2. And in this one to be, 2 over -3. Or sorry, positive 2, and that'd be a -3. Right? So these are your two options of your triangles. But the problem is, we're using the tangent inverse to figure out whatever this angle is. And we know that to evaluate the tangent inverse, our inverse function, or tangent, is restricted within the first and the fourth quadrant. So this triangle we can't evaluate the inverse tangent for this triangle. So therefore, we know that this negative is actually going to be with the 3. Okay, so that's a negative side length, and that's important. Now, fortunately, we're going to be dealing with the cosine. So it could have been, because if you would have had this one, it would have been a negative. So regardless, though, we got to figure out what the hypotenuse is. So in this case, we are going to take 2 squared plus -3 squared, and then equals r squared. So we have 4 plus 9 equals r squared, and then r is always going to be the positive, so that'd be the square root of 13. So now, tangent inverse of negative, that's going to give us our angle beta, and then we're basically just saying, well, what is the cosine then of angle beta? Well, the cosine is going to be adjacent over hypotenuse, so this would be 2 over the square root of 13, and let's just show our work this time, since I embarrassingly got that wrong last time without showing my work. So multiply by the reciprocal, and you get 2 square root of 13 over 13. All right, so now let's get into a little bit more abstract idea is when we have x. Now, obviously, we don't know the value of x, so we don't know if this value is on the unit circle or not on the unit circle. So therefore, since we're still undecided, we're going to have to go the route of the triangle, creating a triangle with the information that we are provided, and then figuring out an algebraic expression that's going to represent with x. So it's kind of like the same idea that we previously did. It's just now we have an unknown. All right, so again, remember, sine is opposite over hypotenuse. So again, I'm going to draw a triangle, and we'll call that theta, and then we'll say 1 over x. All right, so now if they're asking us for cosine, then so this is going to be for our theta. So basically now we're trying to figure out, well, what then is the cosine of theta, right? So using this inverse allows us to create this triangle, create this angle that would provide us that. And now we just need to figure out the cosine of that. So let's label this A. So again, x is going to be our unknown in our value, and we're going to want to kind of figure out what A is in terms of x. So when we do the math here, we get a squared plus 1 squared equals x squared. Right? And therefore we can say a squared is equal to x squared minus 1 square root. A is going to equal the square root of x squared minus 1. So rather than writing this as a, because this is like my new side, I'm going to write this in terms of x. So that would be x squared minus 1. So now when I want to write the cosine, rather than introducing this new variable, I'm going to write this as the square root of x squared minus 1 over my hypotenuse of x. In this next example, you can see we have the cosine inverse. Remember, cosine, we're looking for this angle. But again, in this regard, for this value, this is going to be adjacent over hypotenuse, and we don't have a number for that. So therefore, we can just rewrite that as 1. So kind of like the exact same process here that we're going to do. Let's use a different angle, though. let's use alpha again. Okay, so this is my adjacent side, and this is my hypotenuse. So now we're gonna let's represent this side length with b. Okay, so basically by creating this triangle here for alpha, now I need to figure out what is the tangent of alpha. Well, tangent of alpha is obviously b over x, but let's see if we can determine b in terms of x. And probably in my directions, usually that's going to be stated, which I didn't do because I lumped these together with the other ones. So let's just go and use Pythagorean Theorem again. So we have x squared plus b squared is equal to 1 squared. And again, we're going to want to solve for b because we want to figure out what the value of b is in terms of x. So now I get b squared is equal to 1 minus x squared, and then we'll square root, and b is equal to the square root of 1 minus x squared. And again, everything's positive, so we're assuming we can take this all into the first quadrant. So in this example, we have 1 minus x squared. I don't know why I did that. So the tangent now is 1 minus x squared over x. Okay. All right, last but not least here, we have the tangent. Remember, tangent is opposite over adjacent, so I can create some triangle to represent this. That's going to be beta. And we could say opposite over adjacent. All right, so that's going to create my angle beta. So now I just need to figure out, well, what is the sine of that angle beta based on that triangle that you just represented? And now let's call this C, to figure out our hypotenuse here. So to do that, now to find the sine, again, we're going to opposite over hypotenuse, but we want to write C in terms of x. So again, we'll use the Pythagorean theorem. So we have square root of 2 squared plus x squared is going to equal C squared. Well, this is going to be 2 plus x squared. And if I wanted to solve for C, then I would just take the square root of both sides. So therefore, C equals 2 plus x squared. So in this last example here, so the sine now, so then we can say C is 2 plus x squared. So the sine is going to be x over that, and we don't need to simplify by rationalizing the denominator. If we were going to, we multiply by the radical, then we'd have an answer that would look like this. And that would be 2 plus x squared. Okay, so there you go, ladies and gentlemen. That is basically what we're going to do with the composition when we have values that are not on the unit circle. So again, always look for values that that you're familiar with, the points, the coordinates that are on the unit circle. If so, then you can just use the angles and angles that we refer to on the unit circle to make things easy. However, if you see that you come across a point that is, or a value that is not a coordinate on the unit circle, a coordinate value, or obviously if you have an algebraic expression, then you're going to want to revert back to our understanding of triangles to be able to figure that out. Okay, so the last one is just going to look into some technology of what we're going to use for our trigonometric function. So let's get on to that now.